So, when we are doing stuff algebraically, that means we are using like a letter in place of where you would normally sub in a number. Okay, so we want to use like X or N or Y or A or whatever letter you like. Okay, if I'm going to use, for example, X on its own could be any number, couldn't it? Any value, it could take any value. So if I need it to be an even number, using X is not satisfactory enough because that could be even or odd. However, if I take my number to be 2x, that has to be an even number, doesn't it? Because it does not matter what x is, if I then times it by 2, it will be even, right Harry?
Only if x is equal.
No, x can be anything. If I times it by 2, it will always be even. Yes. Then,
4x is more than 4.
if I wanted a number to be odd, we're just going to talk about this while we're here. If I wanted a number to be odd, having the number x isn't satisfactory enough because that could be even or odd. So, we know, don't times it by 3 because 3 could be even as well.
Oh, you want to times it by something odd?
No, I don't want to times it by something odd. I want to insist it is odd. So to insist it is odd, I know that I can do an even number and add 1 to it.
Oh,
That would make it
genius.
odd, wouldn't it?
Because I don't want
Okay?
either.
Because of the remainder. Because if I have 1 more than an even number, that must be an odd number, because a number is either even or odd.
Unless you're at 0.
Similarly, what else could we use for odd numbers? Shh, stop talking now. What other numbers could we use for odd numbers? 2x plus 1 would work, because that would be odd.
2x minus 1.
2x minus 1, perfect. Another
2x
one.
plus 3.
Perfect. All
Right.
of these
Five.
must be odd numbers.
Plus 7.
Okay? If I needed another even number, how else can I get an even number?
Plus 2.
2x plus 2.
Minus 2.
2x minus 2.
There's no need to do that.
Actually, yeah, we get all of them with it.
Plus 4.
Yeah, 2x plus 4. Okay, good. Any of those would be even numbers. Okay, so if you need it to be even, it's 2x. If you need it to be odd, it's 2x plus 1, or any version that is 1 away from an even number. Okay? Right, so we are in the context of this question. Prove algebraically that the sum of the squares of 2 consecutive even numbers is always a multiple of 4. So I am dealing with even numbers here. So I can say that my first even number is 2x. Everyone okay? That's my first even number that I'm talking about. What would be my next, consecutive being next, what would be my next even number?
4x. 2x plus 2.
Thank you, 2x plus 2. If I wanted my next even number, what would that be? 2x plus 4, good. And then 2x plus 6, 2x plus 8. Okay? If my number is 2x, that's my first even number. My next even number would be 2 higher than that. Okay? So we've got our 2 consecutive, these are consecutive, one after the other, even numbers. Now we need to, so we've done the consecutive bit, we've done the even numbers bit. Now we want the sum of the squares. So the sum of the squares means I need to square my 2 numbers. So I've got to square this number, and I've got to square this number, and it's told me I've got to add them because it asks for the sum of the squares, doesn't it, Amelia? Okay, so the sum of the squares of 2 consecutive even numbers. They are 2 consecutive even numbers. I've got the squares of them, and I'm summing them. Sum means add. After that, it's tidy time. Good. So, 2x all squared. What is 2x all squared, Matt?
4x squared.
Good. And then 2x plus 2 all squared means that we double up our bracket and we expand our bracket. Okay? So 2x times 2x is 4x squared, plus 4x, plus 4x, plus 4. And then tidy. So that simplifies to 8x squared, plus 8x, plus 4. Okay, our question asks us to prove it's always a multiple of 4. How do I demonstrate that this is always a multiple of 4? Jess?
We factorise it.
You factorise it with a 4 on the outside. Good. So you're not factorising it properly, you're just factorising it to suit the question. Okay? So you're just taking out a factor of 4. Let's see if I can actually factorise it this time. Is that right? Okay? I mean, it's not factorisability, it's just factorising the context of this question to show it's a multiple of 4. So now I've taken a 4 outside the bracket. This could be any value, and whatever value it is, if I times it by 4, it will be a multiple of 4, won't it? Okay, so we can say, therefore, a multiple of 4 for all n, x, not n, for all x. Hello, Andrew.
I
Stop it.
understand it, but why